I prepared just a little bit of code there. I introduce you how to use namespace. Okay, so namespace is like packages in Java. So I'm going to create my class. I call it free, and I'm going to put that inside my GPSU namespace. And as you learned from last week, we may need to declare inner classes. My inner classes would be the inner class for my node. Okay, and we know that this class will be a template class. Let me use Z again. Okay, and then my inner class will take the data and a left pointer and a right pointer. Okay, question about node? And I'm going to declare node using forward declaration. Okay, because I need to declare the instance variable will be my root pointer, right? So this pointer to the root node. Question so far? I need a constructor. I need the constructor. You know that. And my constructor will just initialize my root pointer to what? Null. Okay. And I'm going to write my search function here. I'm searching for Z, right? And I'm going to write a private helper function below, and my helper search would be a function that takes 2 parameter, and let me call it start here. Okay, question about the setup. Yes, Jeff.
Why are we using recursion?
Here.
No, why, not
Why?
It seems to me that the linear method of navigation would be either the same or less complicated.
I agree with you.
Okay. I'm good then.
Yeah. I agree, but recursive is more interesting. Okay, and what do I do from my public search? I need just to call search the private search, right? I'm searching for key, and now it has to start searching from the root pointer. Okay, question. And as you know that instead of passing by a value, I want to pass by reference. So I'm going to change that to const ref, because Z can be a structure that we don't know. Maybe like you have like a tree of images. I think I always use images as an example. I don't know why. Okay. So I think, Justin, did you start telling us what to write?
All I said was we need to compare the key to the left and the right.
Yep. If key is
Less than the left.
Less than what?
Left one.
I want to compare. Remember, my node has 3 components, right?
Data.
Yeah. Like that?
That should just be data, shouldn't it?
Yeah.
Data from where?
Or start here, dot there?
Start here. Right? Because that's the current starting point, right? That's the current starting point. Okay? So I want to compare if my key is less than the data at start here. What do?
Go to or call search with
Yep.
pointer data.
Yep. Then you will continue searching, but this time you're going to be searching the same key, but this time you start to the left. That's how you start searching to the left. Okay? And from here, then you will say return, right? Because you have to return true or false. You have to return true or false. Okay? And else, if key is greater than, start here, data, and then you will say return, search, key, start here, right. Okay? And else, then you will say return true, correct?
No. Because it might not be there.
Well, yeah, otherwise it's just equal, so would you want to put the condition, like if they're equal to be first, so we wouldn't have to do those extra comparisons?
So you want to change the order now?
Yeah, just have like one conditional, so if key equals.
Like that?
You have to catch it because it's null false.
Yes.
You gotta do that too.
Yes. Yes. Right? Because remember what happened, as you search, as you continue searching, at some point you may hit a nil. You may hit a null, right? Okay? You may hit a null. Okay? That means we need to first check if start here is null or not. Are you with me? Okay? So then the first thing that I want to do is I first want to check if start here is null pointer, then what do I conclude? Return false. Okay, then probably what we can do is return true there, but else you will need to say else, and I'm just reordering as Alex suggested. Question? Does it make sense? Yes, Joshua.
I think I'm curious about is what does the operator do for you when you compare the greater than or less than?
This one?
Yeah.
Okay, good question. Well, it will depend on your z, right?
Okay.
If z is an integer, it will be comparing less than on integers. If z is a rational number, it will be comparing rational number using less than.
So you're assuming that the object has overloaded the.
Yes.
Okay.
Yep. This will work only if the object z, the class z, overloads the operator less than.
Okay.
Okay? So, for that reason, this is a good thing to do. Okay? So then, that means what? That means I will require my z to overload only the equal sign used here and the less than sign, the less than operator. Just those two required. Okay? Any question? Yes?
How do you require that? Is there a way that you can do that?
So then, for documentation, I'm going to replace z with less or equal comparable.
Okay.
Okay? Just for documentation. The reader of your code knows that the whatever type z must overload the equal, must overload the less than. Okay? And again, let me replace that with less or equal comparable